Hey friends, welcome back to Data Analytics Talks. This playlist, I'm focusing on Cloudera. That is one of the big data technologies. We already mentioned that is a commercial Hadoop distribution. And we have seen the components, the building blocks of Cloudera. And the last session, we have seen what is Hadoop. And in this video, I would like to focus on the HDFS. So what is HDFS? HDFS is Hadoop Distributed File System. So before we understanding HDFS, we would understand what is the file system and what is DFS, Distributed File System, and we will come to HDFS, that is Hadoop Distributed File System. Okay, let me share my screen and explain you more details about the distributed file system. So welcome back. It's all about HDFS. HDFS is Hadoop Distributed File System. So before we understand HDFS, it is always good to understand what is a file system. I know everybody knows what is file system, isn't it? So a file system is a kind of data structure or a method which we use in operating systems to manage file on local disk or disk space. So we have different types of operating systems. We have Windows, we have Linux. So in every operating system, we have to manage your file. We have to manage your files. That means you have to allow the user to keep the file and retrieve the file, right? The file could be of different sizes. It could be sometimes huge, of terabyte, petabytes. So if you have already experience with Windows operating system, I know that we have examples of Windows file system called NDFS, New Technology File System. And we have the FAT32, the file allocation table. Maybe in the previous version of Windows operating system, we had the FAT32. So now we know what is file system. So now we would like to explore about some local file system and the DFS. When I say local file system, this is not distributed. So you put all your files, whether it is a small or big, you put into one basket, one node, one machine. Just like this. Okay, we have the total of the file size, the space is 10 terabytes, and you are able to manage, put your data into that file system. But when it comes to DFS, it stands for Distributed File System. It is a concept of storing the file in multiple nodes in a distributed manner. So DFS actually provides the abstraction for a single large system whose storage is equal to the sum of storage of other nodes in a cluster. So let's understand this with an example. Suppose you have a DFS, Distributed File System, comprising of 4 nodes. Node 1, node 2, node 3, node 4. And each node has the disk space, maximum is 10 terabyte. And if you are asked the size of the distributed file system, it is 40 terabytes. This is not the actual, but it is an abstraction of the sum of all the nodes, right? This, you have a file with 30 terabytes. So you can go and distribute that file across these multiple nodes, right? So it is not storing in one node, it is storing across all these 4 nodes. So that's the core of distributed file system. So why do we need the DFS? That is the question. So you might be thinking that, so we can store this 30 terabytes if we have a larger disk space in a single node. Then why we need this DFS? So this is because the disk capacity of a system can only increase up to certain extent. We cannot make it as a lakhs of terabytes. We can only scale up to a certain limit, right? So if someone wants to manage the data on a single system, you will face a lot of problems, especially the processing time. So because of that, we are going with the DFS. For example, on a single machine, it will take to process a 50 terabytes of file in 5 hours. But sometimes the same case, if you use distributed file system, it can reduce to 1 hour. So in that case, as you see in the below image, the file of size 40 TB is distributed among 4 nodes. In a cluster, each node store 10 terabytes. Right? We have 4 nodes, and each node store 10 terabytes, and the total is 40 terabytes. And during the process, all these nodes are working simultaneously. All these nodes are working simultaneously. That is why it is reducing the 5 hours into 1 hour. So that is why the DFS is faster. So now we think you are familiar with this distributed file system. Now we need to understand what is Hadoop Distributed File System. So coming to the definition of HDFS, it stands for Hadoop Distributed File System. So it's distributed file system designed to run on commodity hardware. So HDFS is highly fault tolerant and is designed to be developed on low-cost hardware. So it provides high throughput, access to application data, and is suitable for application with larger data set. HDFS is capable of handling larger size of data with high volume velocity, and variety makes Hadoop work more efficient and reliable with easy access to all its components. So HDFS stores the data in the form of block, where the size of each data block is 128 MB in size, which is configurable. Means you can change the block size. NameNode. So when I look at the HDFS architecture, we can understand that it follows a master-slave architecture. It consists of different components, and majorly you will see NameNode and DataNodes and local disk. So NameNode serves as a central metadata management node in HDFS. It solely stores the metadata. It's a metadata management. So it stores crucial information about the file system's directory structure, file names, and attributes. The NameNodes track the location of data blocks across data nodes and orchestrate the operations, including reading, writing, and replication. When it comes to data node, it stores the actual data blocks of the file. They receive instruction from the NameNodes for read and write operation. It ensures fault tolerance through data replication. So remember the master-slave architecture of the DFS architecture. Then coming to the important feature of DFS, it is easy to access the file stored in HDFS. HDFS also provides high availability and fault tolerance, provides scalability to scale up and scale down nodes as per the requirement. Data is stored in distributed manner, various data nodes responsible for storing data. HDFS provide replication, because of which no fear of data loss. HDFS provide high reliability as it can store data in a large range of petabytes. HDFS has inbuilt servers in NameNode and DataNode that help them to easily retrieve the cluster information. And finally, it provides high throughput. And how does HDFS work? Maybe that's the last point we are going to discuss. So HDFS enables scalable storage, retrieval, and processing of data through its distributed and fault-tolerant design. It optimizes read and write operations. It ensures data redundancy and incorporates algorithms for efficient data management. It boosts big data analytics by distributing data across clusters. And the read and write operation. HDFS enables seamless and scalable read and write operations through distributed data nodes and metadata management. Okay, that's all about HDFS. Let's explore ourselves and let you know more about HDFS, Hadoop Distributed File System. Thank you.